It's one of the most intriguing locations in the world. Covered in darkness and miles underwater, this extreme environment is home to some unusual creatures and phenomena. It's called the Mariana Trench, and it's the deepest oceanic trench on Earth. No wonder it's been so difficult to explore. Because of the risky conditions, people aren't able to explore this location without proper equipment. But what would happen if we threw a steel ball down there? Let's start with some basics. How did they first discover this enormously deep hole in the ocean? HMS Challenger identified it back in 1875. The ship had some pretty fancy sounding equipment for its time, but it wasn't nearly good enough to be able to fully explore the trench. Some decades later, in 1951, another ship, the HMS Challenger II, came back to the location better equipped. The vessel featured an echo sounder and was able to take accurate measurements of what seemed to be the deepest point on the surface of our planet. If you were to look at it in 2D, you'd see the trench measures 1,500 miles in length and 43 miles in width on average. It also looks sort of like a crescent-shaped scar when you observe it from above. Nothing out of the ordinary so far, right? Well, if you were to stretch a wire from the surface of the ocean to the trench's deepest point, it would measure a staggering 7 miles. If we were able to physically move Mount Everest, which is the Earth's tallest mountain, to cover the Mariana Trench, it still wouldn't be enough, falling short by about a mile. Because the Mariana Trench is so deep, it's almost completely covered in darkness, as light can barely get through to such extreme distances underwater. The temperature isn't any friendlier either, just a few degrees above freezing. But the most dangerous feature of them all is the water pressure. Right at the deepest point of the trench, the amount of pressure is about 1,000 times higher than the standard atmospheric pressure. Not a lot of people ever attempted to descend into the Mariana Trench. In fact, the first organized attempt took place more than 60 years ago. It was done by Jacques Piccard and Don Walsh in a submersible. They only spent about 5 hours on their descent and a mere 20 minutes at the bottom. Alas, they weren't able to take any pictures. Until these two scientists were able to descend, specialists believed there was little to no chance that life could exist down there, given the conditions, most notably the extreme pressure. But while at the bottom, the submersible's floodlight caught sight of a creature. It was a very flat one indeed. As you can imagine, resources here are very scarce. What kind of creatures live down here? And how do they survive, given the harsh environment? Surprisingly, there is quite an abundance of wildlife living in the Mariana Trench. Some of these creatures fall back on chemicals to survive, like methane or sulfur, while other kinds of fish nibble at the marine life that's, well, weaker than them on the food chain. The most common creatures found here are xenophyophores, amphipods, and small sea cucumbers. Some of them adapted by hardening up their shell using aluminum harnessed from the seawater. Smaller creatures, like microbes, adapted by feeding on the chemicals emitted when the seawater hits the underwater rocks. They consider the Mariana snailfish the rock star of the area in terms of wildlife. They're small, ranging from 3 to 9 inches, translucent, and lacking any scales. But they're the top beast of prey in the area. It's no wonder some people started to believe that the ancient Megalodon might still be living here. What was a Megalodon, you might be wondering? It was the largest predator ever known in our planet's history. Basically, the biggest and nastiest shark ever to have lived. Scientists believe it's been extinct for quite some time, and the idea that it might still be hiding in the Mariana Trench doesn't have a lot of supporting information. The Megalodon would have needed to learn to navigate in complete darkness. It would either have to be bioluminescent or evolve to have massive eyes. More so, because of its school bus-like size, the Megalodon would have needed a lot to eat. Microbes and small snailfish just wouldn't have done the trick. If a steel ball were to be dropped in the trench, what would be its effect on it? Would the ball be strong enough to sustain such pressure? Let's look at the science here. If we assume it's a solid steel ball, the pressure found at the bottom of the trench wouldn't be enough to really affect it and cause permanent damage. It would take it a solid 12 minutes to reach the bottom of the ocean, though. What about the temperature? Well, It turns out that the difference in temperature on the surface and at the bottom of the trench is quite impressive, a difference of about 86 degrees Fahrenheit. So, it would cause the ball to shrink a bit, but yet again, once the ball returns to the surface, it would simply come back to normal. Should the ball get stuck there, there's another interesting question to answer. Would corrosion affect it? Corrosion of steel is highly dependent on the amount of oxygen in the water. The amount of oxygen dissolved in water remains constant at depths greater than 3 miles. I'll spare you the math, but it would take more than 10,000 years for the steel ball to completely rust under the sea. I can't help but wonder though, what would it take us humans to be able to survive at such extreme depths? Let's look at what was used in the past to explore this mysterious location. A little thing called syntactic foam. Why? Because it's the only material that can both float and resist the amount of pressure found here. Without this sort of protection, our lungs would rapidly collapse here. More so, the pressure from the water would push liquid into our mouths, replacing the much-needed oxygen with water. Then, there would be the much-needed ability to be able to come back to the surface, should anything not go as planned. One of the vessels that went for a deep dive here had 1,000-pound steel weights attached to it, so it would ensure its sinkage. These weights were connected to the ship by a special type of wire that had an increased corroding time of 11 to 13 hours in seawater, just in case something went wrong down there, and they'd have to bounce back faster. Given the harsh conditions here, the problem of oxygen supply is really important too. Any vessel looking to descend into the Mariana Trench again would need to consider some sort of device that can recycle the air in order to reduce the amount of oxygen that needs to be transported down there. And the last, but definitely not the least of all problems, would be electricity. There surely isn't a power socket down there for you to charge your phone. So, there needs to be enough battery life to support all the necessary equipment, communication, oxygen supply, lighting devices, and so on. None of these problems seem to be quite the challenge anymore, since, as of recently, you can buy a tour of the Mariana Trench. 3 lucky individuals were part of such a project back in 2020. They were submerged in a 3.5-inch thick titanium sphere. This ensured that they didn't feel any pressure changes and physiological stresses whatsoever. Each of the guests took part in an individual trip that had an estimated length of about 14 hours. The descent itself took over 4 hours. Once they reached the bottom, they got the chance to witness some of the most extraordinary creatures on the planet. Then it was time to start the 4-hour ascent back to the surface.
Can you swim? Good. Because you're going on a journey to the deepest point of the Pacific Ocean. Now, put on your flippers. The very bottom of the Mariana Trench is awaiting. Now, get in the water. Really, come on. All right. 1 foot underwater. That's the depth you can swim with no special gear like a mask. Hey look, must be some tourists. Or whales. 10 feet underwater. That's a little deeper than the public pools and beaches around the United States. You can see colorful fish and even phytoplankton that feed on the sun's rays. 26 feet down. This is the depth at which the foundations of the floating city of Venice in Italy stand. Builders laid columns at that depth on which they later built houses and streets. 30 feet underwater. You start to feel a lot of pressure. When you're on the surface, you're under atmospheric pressure, 15 pounds per square inch. But here, at 30 feet, that pressure is doubled. All the air pockets in your body, like your lungs or ears, begin to compress from this pressure, giving you discomfort. But no worries, your organs are soft and elastic, so you can keep diving. 40 feet underwater. Oops, you're running out of air. An average person can hold their breath for 30 to 90 seconds. The current record is an incredible 24 minutes and 37 seconds. Gasp. Okay, you'll need some diving equipment to continue your descent. There you go. Thank you very much. Tourists dive to this depth to look at reefs and corals. You don't need special skills for that, but you can't dive any deeper without training or a license. 45 feet down. Be careful. There's sharks swimming here looking for food, like you. Sometimes tourists descend to this depth in a safe cage to see the sharks up close. You're better off staying away from these predators and not attracting their attention. So make sure you're not wearing any bright and shiny jewelry. Sharks love that kind of thing. 62 feet underwater. You could see the Aquarius Reef Base Lab in Florida at this depth, if you were in Florida. It's really an entire building with rooms for exploring the seafloor, accessible through a hatch. 105 feet down. You see a strange bell hanging from a chain. People used to use these things for deep diving about 400 years ago. They'd lower a bell on chains with divers inside from a ship. There was enough air inside the bell for them to breathe. That way, they could explore sunken ships with treasures. 140 feet. At this depth, you could find an entire sunken city in Qianda Lake, China. You can still see streets, houses, and temples there. 330 feet. Whoa! You almost hit a huge blue whale. How could you miss it? These guys, the size of 2 train cars, usually dive to that depth. Shh! Let's listen to them sing for a while. It's beautiful. Now, let's keep going. 660 feet. This is where most of the ocean life ends. Sun rays hardly penetrate any deeper into the water. Everything below are unusual fish like this angler. They have such an unusual appearance because they have to adapt to the high pressure here. 702 feet underwater. This is the last mark where you'd see a human without diving equipment. This man holds the title of the deepest man on Earth, and he's the only one who has managed to get to this depth. The water pressure on his body here was 20 times greater than that on the surface. 985 feet. Ooh, what was that sound? Whoa, that's a submarine. That's the maximum depth they can dive to. Some of them can reach speeds of 26 miles per hour. Fun fact, an ostrich can run twice as fast, but she can't swim. 1,090 feet. Say bye to this scuba diver. You won't see them any deeper than this. The world record was set in the Red Sea. It only took the diver 12 minutes to reach this depth, but it took him a whole 15 hours to return to the surface to avoid decompression sickness. So now you get an atmospheric deep diving suit. It's completely sealed, and you won't feel the insane water pressure on your body in it. 1,454 feet. If you stuck the Empire State Building in the water, its tip would be here, and all the carpet inside of it would be wet. 2,300 feet down. The water pressure here is 70 times greater than on the surface. The flexible plastic parts of your suit can't withstand that kind of pressure. So here's some urgent delivery. It's an ultra-deep submersible. Now you can continue your dive all the way down. 2,717 feet. Here you'd see the tip of the tallest building on Earth, the Burj Khalifa. Alright, who's sinking all the tall buildings around here? 5,387 feet. This is the depth of one of the oldest and deepest lakes in the world, Lake Baikal. Its area is slightly larger than the entire country of Belgium. 8,040 feet. That's the record depth the Perdido oil platform reaches in the Gulf of Mexico, and its above-water part with 3 decks is almost as high as the Eiffel Tower. 11,962 feet. This is the average depth of the Atlantic Ocean. You can see a huge tube as wide as a giraffe's neck, and it just seems to be endless. True, this cable connected Europe and North America and used to serve for telegraph communications. 12,303 feet underwater. Suddenly, in the darkness, you see the outline of a ship. No way! That's the Titanic itself. The intense water pressure would crush a person at this depth, so you can only dive down to the Titanic in a submarine. 13,123 feet. Whoa! Here would be the end of the deepest mine in the world, Imponen Gold Mine in Africa. But you still have deeper places to go. Let's speed up. 20,000 feet. Here you can see the deepest debris of an old ship. The USS Johnson sank more than 70 years ago. You can still clearly see the number 557 on its bow. 26,200 feet. Here, in this total darkness, you'll find the deepest fish in the world, the Mariana snailfish. They're as long as a domestic kitten and have almost transparent skin. Their eyes are poorly developed for vision because the sunlight never reaches this deep. 29,030 feet. If you take Mount Everest, flip it over, and stick it into the Marianas Trench, this is exactly where you'd see its tip. Even though this is the highest point on our planet, you'd still have a lot deeper to go. 35,755 feet down. Here, in the Challenger Deep, you'd still see life. You'd need a microscope for that, though. Bacteria living here feed on organic molecules, similar to oil. A little deeper? Congrats! You've touched the bottom. It's 36,070 feet deep. The pressure here is 1,071 times higher than on the surface. But you're not the first person to have been here. One of the last expeditions to the bottom of the Mariana Trench was in 2012. An American filmmaker descended here in a submarine he designed himself. But the pressure broke some of the engines, so it was hard for him to maneuver here. The sonar was also damaged, and some of the batteries drained. He was in the Challenger Deep for about 3 hours and took many pictures and videos. If you look closely at the bottom itself, you can see bubbles. It's carbon dioxide and liquid sulfur. It's freezing here because of the extreme pressure and temperature close to freezing. But there's still life here in these harsh conditions. The 3 microorganisms are most common here: xenophytophores, amphipods, and small sea cucumbers. There's so few of them because they don't have enough food down here. Usually, there's a lot of palm leaves on the ocean floor, which get there from the land. But the Mariana Trench is 124 miles from the nearest islands. So the only food here is old plankton and fish scales from the ocean's upper layers. But it needs to travel tens of thousands of feet to become food for the bottom dwellers. But can you go even lower into the crust of the Earth? Well then, you'll need to unleash your giant drill and fire up the jet engines. You're pushing another 36 miles through the Earth's crust, and here is its edge. You've entered the upper mantle. It's an ocean of hot lava, 1,800 miles deep. You have to literally swim through this, reaching the outer core, another 1,400 miles deep. Then you reach the inner core, another 755 miles, and congrats! You're at the very center of the Earth. I hate to ask, but how do we get out of here?
The Mariana Trench in the western Pacific Ocean is the deepest place on our planet. If you throw a rock into the water, it'll travel 36,000 feet before touching the bottom. But unlike your body, the rock won't experience any unpleasant consequences. After all, it doesn't get affected by all that immense pressure that builds up the deeper you go. But then, what would happen to your body at the very bottom of the Mariana Trench? Put on your flippers. It's time to dive. Hold your breath. You're 5 feet below the surface, and it's still pretty comfortable down there. You're used to this depth. You go that deep when diving in the pool, or maybe at the beach when watching exotic fish swimming near the bottom. But you're serious about reaching the deepest point of the Mariana Trench, the Challenger Deep. So you keep going. 32 feet. That's where you start to feel some discomfort. Here, the pressure pushing down on your body has doubled. Your ears and lungs feel a little sore. This is because people have many air pockets in their bodies. And under pressure, these pockets shrink in volume, and you can feel it. But don't worry, your organs aren't made of metal. They're flexible enough to withstand even more pressure than that. What you should worry about at this depth is the white shark. If it wants you for dinner, you're in worse trouble than high pressure. That's why you'd better keep diving. Around 65 feet underwater. That's where you'll need a flashlight and air tanks as you're running out of breath. The sun's rays barely reach here, and it's pretty dark. For the same reason, you're getting cold. How about putting on a thermal suit, which is what divers usually wear? Ah, it's better now. But even though you feel warmer, your ears are starting to hurt a lot. And your lungs have shrunk almost 3 times their normal size. This can be risky for an untrained diver. But you're brave enough, and now you're already at a depth of 100 feet. Only professional divers go that deep without special equipment. The pressure here is 3 times higher than what you experience on the surface. Something weird starts happening to your body. It's not like anything you've ever felt before. And the reason is your air tank. The The compressed air inside is mostly nitrogen, 78%, and oxygen, around 21%. But that deep down, nitrogen becomes kinda toxic. It can make you do strange things, like you may forget you're underwater and pull off your oxygen mask. But if you take tanks with more oxygen in them, the dizziness and other strange sensations will pass. 200 feet below the surface, the pressure here is 7 times higher than on dry land. Now, even the oxygen becomes unsafe to you. You have to breathe some gas with helium in it. A sharp drop to a depth of 700 feet. This mark is the world record in free diving. Herbert Nitsch once managed to reach that deep without any special equipment or air tanks. After that, he received the title of the deepest man on Earth. In 2012, he tried to break his own record and plunged to a depth of 830 feet. But it didn't end well for his health. Anyway, if you trained to hold your breath for that long, you would probably have very few problems now. That deep down, you need to start looking around again because there can be heavy traffic. Submarines travel at this depth, and you sure don't want to collide with one of them. A few more feet deeper, and you've reached the limits of the average human's body. At the same time, laboratory experiments have proven that people can withstand even higher pressure. It went like this. A diver entered a special chamber the size of a room. Scientists simulated high pressure, comparable to a deep dive, inside this chamber. This way, the researchers discovered that a trained person can withstand the pressure similar to that at a depth of 1,600 feet. But the diver couldn't just walk out of the chamber after the experiment was over. At high pressure, nitrogen, helium, and other gases build up in the body. And if you normalize the pressure at once, those gases form into bubbles. The consequences are extremely unpleasant, to say the least. So, you have to do a gradual ascent from this depth. This way, the gases can leave your body in a natural way. Sometimes a dive takes a few minutes, but coming to the surface stretches for many hours. It's all about safety. Okay, now you have to put on a special suit. Otherwise, you won't be able to dive any deeper. It can protect you at a depth of up to 2,300 feet. The suit's sealed, and the pressure inside is exactly the same as on the surface. But all too soon, the suit's protection isn't enough anymore. You need a new means to continue your descent. And that's the Triton 6600 submarine. Now that you're sitting inside a large iron machine, you feel as if you're driving a car. Only this vehicle is worth $5.5 million. You certainly don't want to smash it, so be careful. You've reached a depth of 6,600 feet. Don't even think about getting out of the submarine. The pressure here is 200 times greater than on the surface. Your body just won't survive this experience. There's still almost 30,000 feet to the bottom of the Mariana Trench. If you teleported right there, a huge column of water nearly 7 miles high would press down on you with all its force. Your sightseeing tour would be over before it began. Even pressurized submarines can't withstand that kind of force. Large metal machines just burst like air balloons. At the moment, people only explore the bottom of the Mariana Trench with the help of robots and drones. One such machine is Nereus. This is an autonomous underwater vehicle that was built specifically for deep-sea diving. It can withstand pressures 1,000 times greater than those on the surface and reach a depth of nearly 36,000 feet. In May 2009, Nereus got to the bottom of the Challenger Deep, the deepest known point on our planet. Thanks to this machine and its 2 cameras, people could watch what was going on at that enormous depth. But people have also set foot in the Challenger Deep. Back in 1960, the Trieste bath escape descended to its bottom. The vessel was carrying 2 crew members. Unfortunately, they couldn't see their surroundings well. There was only one small window in the bath escape. It helped the structure of the ship remain strong. Plus, to withstand the incredible pressure, the iron walls of the bath escape were 5 inches thick. But when the explorers reached the ocean floor in the Challenger Deep, one of the window's panes did crack. Luckily, the ship was still able to spend about 20 minutes at the bottom of the ocean and then rise to the surface. But there are living creatures that are used to such incredible conditions. The Mariana snailfish, for example, lives at a depth of 24,000 feet. Even the bottom of the Mariana Trench is inhabited. Bacteria and viruses live there. They're used to low temperatures and high pressure. And their food is all kinds of organic matter that sinks to the bottom of the ocean. People can also survive in other extreme conditions. For example, in space. It's a vacuum. Unlike what many people believe, it's not cold. It's also not as dense as air or water. That's why you'd lose your body heat very slowly. But you can do an experiment. Normally, water boils at 212 degrees Fahrenheit. Let's say you place a glass of water in a special chamber and gradually lower the pressure. The lower it is, the lower temperature the water needs to boil. You're 70% water. And since space is an almost absolute vacuum, the pressure there is extremely low, near zero. And now, think about what can happen with your very liquid blood. I believe you can imagine the consequences. Ouch. Also, your internal organs would begin to expand. But that's not a problem. Your tissues are flexible and can withstand such an experience. The main issue would be the lack of oxygen. Without air, you'd soon lose consciousness. And still, if the rescue team could get to you within 1 to 2 minutes, you'd be fine. But there are living organisms that can survive even there. One bacterial species was thriving in outer space near the International Space Station for 3 years. These bacteria don't mind the vacuum and the lack of oxygen. They've even managed to survive strong solar radiation. They rightfully deserve the title of the world's most resistant bacteria.
Wanna high-five a sea creature? Well, put your hand up for the Tasmanian red handfish. This fish doesn't swim like a fish. It walks. It uses its flipper-like hands to stroll around on the ocean floor. These bottom walkers are disturbed by swimmers and boats a lot. Some people even want to take them home as pets. I think it's better to just give them a wave and swim on by. The vampire squid. Its species name is Vampiroteuthis infernalis, which translates to vampire squid from hell. Oh yes, this vampire squid means to terrify everyone with its name, its dark red color, its spikes at the bottom, and the scary fact that it can basically turn itself inside out. The vampire squid loves putting on a good show, but it's as harmless as a kitten is to humans. It's as if Dracula scared the pants off you, but he didn't have blood-sucking fangs. The vampire squid feeds on food particles from plants and animal matter floating near the ocean's surface. Since they're not predators, they need good defensive strategies, and their vampiric look is designed to ward off large creatures who want to eat them. Turning themselves inside out is a defensive mechanism since the spiky areas in the inner skin are more intimidating. They also shoot out a substance that does not have color, but is packed with bioluminescent particles to distract predators. The vaquita. Going out on a boat off the coast of Mexico sounds like the perfect vacation. The sun, the blue water, the most endangered sea creature. Wait, what? The vaquita isn't dangerous, but don't expect it to stick around to say hello or sign any autographs. It's incredibly shy. This little cow, that's what it means in Spanish, is one tiny sea mammal. With those black markings around its eyes, it looks more like a sea panda to me. Seeing one should make you feel very special. They're on the brink of extinction, mostly because they got caught by accident in fishing nets. It's estimated that there's only 10 left in the wild. The blue dragon. This little creature looks like something out of a kid's fantasy movie. It's called the blue glaucus, casually referred to as the blue dragon or blue angel. It can be found in many places, the Atlantic, Pacific, and Indian Oceans. It's kind of a mollusk and it only grows to be about an inch long. What you think is the back is actually the mollusk's bright underbelly. It regularly floats on its back so that its blue colors help it camouflage with the water's waves. The blue dragon isn't just pretty, it's also smart. It usually feasts on Portuguese man-o'-wars, also known as Physalia physalis. The blue dragon stores their stinging cells for later use, in essence, stealing their defensive mechanisms. When the blue dragon is threatened, it releases those stinging cells it stored, directing them at an enemy to sting them with more power than the Portuguese man-o-war would have been capable of. As they can store a huge amount of stinging cells, they can be a threat to humans. So, if you find one, don't pick it up. It's best to admire it from a distance. The barreleye fish. If you ever wanted to have Superman's X-ray vision, looking at the barreleye fish will make you feel like you gained that superpower at some point in your life without even realizing it. The barreleye has a transparent head, so you can see how their eyes and brain look inside. This magnificent creature lives in the deep sea. This is the lowest level of the ocean, where strange creatures roam in near-freezing temperatures and constant darkness. They're exposed to water's pressure that's almost 1,000 times that of the surface. If the idea of the deep sea sends a shiver down your spine, stay tuned to learn about another of its creatures later on. The barreleye fish can be found in the Atlantic, Pacific, and Indian Oceans. You might be wondering, why oh why would a fish have a see-through head? And that would be a fair question. Since the species was discovered in 1939, it was believed that the fish's eyes were set to see straight ahead and couldn't move, so it was assumed that they had tunnel vision. Scientists Bruce Robinson and Kim Reisenbichler from the Monterey Bay Aquarium Research Institute recently discovered that the fish can move its eyes vertically to see through the top of its translucent head, thus noticing if there are predators or prey nearby. The transparent head also allows more light to enter so they can detect prey better. It's believed that the barreleye fish eats jellyfish and small fish species. If you dive in the ocean at night, you might be lucky enough to see how orange ball corallomorph blooms in the dark. But make sure to be quick because as soon as you turn on your flashlight to take a good look, it will retract its tubes back into itself. The Megalodon. The whale shark isn't the biggest shark known to humans. If the entire shark species were a kingdom, the prehistoric Megalodon would be the ruler of the sea. Megalodon roamed the ocean a long time ago. About 15.9 to 2.6 million years back between the early Miocene and late Pliocene eras. While they've long been extinct, people are still amazed to learn about these gigantic sea beasts. Megalodon could reach anywhere between 45 feet to 60 feet in length with jaws more than 6 feet wide. A fossil of a tooth that once belonged to a Megalodon measured at 7 inches. Needless to say, I'm pretty stoked that these guys have long been extinct. But there's still some adventurers out there hoping to meet this monster one day. The Dumbo Octopus. This adorable creature, or creepy creature, or however you want to see it, is officially called Grimpoteuthis. More casually, it's referred to as the Dumbo octopus, named after the Disney character. Though Dumbo, the elephant, not the octopus, was teased for his big ears, it's highly unlikely that this adorable octopus gets teased by its water neighbors. They are the deepest living octopuses, living in the deep sea, and you know how scary that place is. They're only about 8 inches tall and spend their days hovering just above the seafloor eating snails, worms, and other food they find in the current or near ocean vents. There are nearly 17 species of Dumbo octopus, and they all have differences in height, color, and body parts. If you can't get enough strange animals, you'll be glad to learn that the deep sea has barely been explored by humans. So keep an eye out. There are bound to be more fascinating animals discovered in the deep in the future. The sea angel. These creatures might look and sound pretty cute, but their diet is far from sunshine and lollipops. Their favorite food are sea butterflies. They lay mucus traps for them and wait in ambush. The squat anemone shrimp. This shrimp is tiny, only 0.5 inches. It's also known as a dancer shrimp because of its peculiar behavior. When agitated, it raises its bottom above its head and does a little dance. Divers also say it readily jumps on their hands and cleans them. The coconut crab. This guy may look pretty creepy, especially when the sun goes down. Mature coconut crabs are around 3 feet in length. Their preferred foods are coconuts, but they can also hunt down lizards and even large birds. The slender snipe eel. Slender snipe eel is a slim and long creature that's still a mystery for marine scientists. It's 4 feet long and it has at least 750 bones in its spine. which is much more than any other animal in the world. The sea pen. Sea pen is 7 feet long and it has a lot of varieties, but most of them look indeed like a pen or a quill. The similarity is even more striking when the animal has a water-filled bulb that anchors it to the floor. The Persian carpet flatworm. This creature looks indeed like a carpet, despite being very small by comparison. It's only 4 inches long, able to become both male and female. It doesn't really mate with other flatworms. Rather, it fights them for the right to bear posterity. The flamingo-tongued sea snails. Tourists love these extraordinary snails for their pretty colors, thinking it's a shell, but in fact, the shell is quite dull and hidden underneath colorful soft tissues. They eat softer, toxic parts of corals and store their toxins to protect themselves.
Hello, Brightsiders! Do you know where the deepest place in the world is? I think it's in the Pacific Ocean, near the Philippines and Papua New Guinea. It's the famous Mariana Trench. So let's take a tape measure, a very long one, and attach its end to the boat on the surface. Now we hold our breath and jump in the water. Fish and marine animals swim by. We descend lower to the depths and into total darkness. And after several hours, we reach Challenger Deep. The tape measure shows a depth of 36,200 feet. The famous Mariana Trench is not the deepest place on Earth, as everybody thought. The Kola super deep borehole located in Murmansk region in Russia beats it by a wide margin. And scientists have discovered something unusual and sinister there. When geologists were drilling the hole, they could reach the depth of 9 miles. And then they encountered voids. Scientists on the surface were surprised and scratched their heads and then decided to lower a microphone and dozens of other sensors in these voids. The temperature down below turned out to be 2,000 degrees Fahrenheit. And the microphone recorded something that sounded like human groans and screams. Many people thought the scientists had been able to drill into the underworld. The shocked people up above had already begun to panic, but suddenly an unknown creature jumped out of the drill pipe. It looked like a black goat that walked on its hind legs. Its body was shrouded in black flames. The creature got out of those deep hollows and ran off into an unknown direction. Okay, wait. These are just myths that one newspaper published on the 1st of April. It's International Joke Day, by the way, but many people believed it. It made many believe the scientists working at the borehole had opened a portal to the nether, and that now horrible, outworldly creatures were free from their imprisonment. But like with any myth, there's some truth to it. The deeper the scientists drilled, the higher the temperature got. At 3 miles deep, it was 160 degrees. At 4.5 miles, it was 250. And at the maximum depth of 7.5 miles, the sensors recorded a temperature of 413 degrees. One day, scientists heard a loud explosion underground. They stopped working and everyone tried to find out what caused such a loud pop. But there was seemingly nothing there. After a while, they continued drilling deeper, and at the same depth, no accidents happened. The drilling began in May 1970. They passed the first 4.5 miles quite easily, and it was primarily hard granite rock. It was like drilling through a hard wall. But then their drill went into softer layers, and the shaft of the hole began to crumble. It was like drilling in wet sand. Every time the workers took the drill out, there was a risk that the hole would collapse under its own weight. As that eventually happened, the scientists picked a new direction to drill, and you know what's interesting? In the end, the map of the entire well looked not like a straight beam from top to bottom, but like a tree trunk which had diverged into many different routes. 9 years later, scientists reached the depth of 31,400 feet and broke the world record for the deepest borehole. By 1983, they made it another 8,000 feet deeper. After a brief pause in the work, there was an accident. A part of the drill broke away from the main body and remained in the borehole. For several months, scientists tried to extract the drill, but nothing worked, and they had to return to the depth of 4.5 miles and start all over again. The drill was divided into sections, and one such unit could only last about 4 hours before it had to be replaced. In terms of depth, that was only about 32 feet of drilling. Then the drill was lifted to the surface, replaced, and lowered back down. On average, the drilling speed was about 200 feet per month. That's like a 20-story building. In 1990, 20 years after the work had begun, scientists reached the final depth of 40,230 feet. That's like 100 soccer fields down. And after another accident, the work stopped. Guinness World Records registered the Kola Super Deep Borehole as the deepest borehole in the world. It's like Mount Everest plus 9 Empire State Buildings on top of it. One of the most unusual discoveries at the Kola Super Deep Borehole was that the soil at the depth of about 2 miles almost perfectly matches the composition of the surface of the moon. It has given us more insight into how our ancient satellite appeared and formed. It seems that in the early stages of Earth's formation, a giant asteroid crashed into our planet. With that kind of force, it caused an explosion so powerful that part of our planet broke off and flew upward. This chunk of Earth remained in our planet's orbit, cooled, and later formed into the moon we know today. Another surprise for the workers was the presence of gold. There was about 2.5 ounces of gold for every ton of soil lifted. The deeper the scientists went, the older the rocks were. In layers of rock about 2.8 billion years old, they found fossilized remains of living organisms. It made the world of science bubble with excitement, as it meant that life on our planet appeared 1.5 billion years earlier than first thought. In the early 1990s, they shut down the drilling project. Gradually, the buildings around the borehole and the drilling equipment were lost. Today, a lot of tourists visit the place. It's because of those same myths about creatures from the underworld. Yes, there's a hole 7.5 miles deep under that rusty lid. But the scientists working there never reached their goal. They wanted to drill into the Earth's mantle, but to do that, they would have had to dig down to a depth of about 44 miles. At 200 feet per month, it would have taken as long as 80 years. That's assuming no accidents happened. But the deeper it goes, the more interesting it gets. A few years ago, they found a massive amount of water deep underground. Somewhere up to 370 miles down, there's a substantial ocean billions of years old, and the amount of water there is several times greater than in all the oceans, seas, and rivers combined on the surface of Earth. The water there is at a scorching 2,800 degrees Fahrenheit. But because it's under a tremendous pressure, it doesn't evaporate. It's encased in a crystalline structure of minerals. This ocean was formed in the early stages of our planet's development, when there was only hot lava and debris of space bodies around. But the most exciting thing you can find by drilling is living organisms. They've been there in isolation for billions of years, and they can give us clues as to how life came into being in the first place. Scientists in Antarctica have created a similar borehole, An entire lake half the size of Lake Ontario was discovered under the thick ice. The amount of water in this lake is only 3.5 times less than in the Lake Baikal, the largest lake on Earth by volume. The ice that hides this lake is at least 20,000 years old, and the water beneath it has been isolated from the outside world for about 15 million years. While drilling, scientists lifted a chunk of ice from deep down below and found an unknown bacterium on it. Its genetic code was only 86% similar to known living organisms. That means that we've never seen bacteria like this before, or it had come from outer space. But that's just a theory. We know that these bacteria can live in unusual conditions and at water temperatures below freezing. The composition of underground lake water is also different from what we're used to. There's a lot more oxygen and carbon dioxide in it. Add to these conditions complete isolation, and we get living organisms that have developed and evolved in a completely different way. Do you understand what it means? The study of deep organisms may give us a clue as to whether life could exist beneath the ice on other planets or their moons. For example, Saturn's moon, Enceladus, has ice 24 miles thick. There may be an ocean underneath, which is heated by thermal springs. That's all for today. And guys, remember, let's become smarter every day together with Brightside.
Most of the ocean is still shrouded in mystery, whether we're talking about dark corners or creatures that are hiding in the depths. But sometimes it gives us a peek into scary things it hides in its cold, dark depths. Like when you hear on the news that there are some deep sea creatures washed ashore after a powerful storm once again. Some just look weird, while others are real monsters that live at depths of more than 3,300 feet. The coldest and deepest parts of the ocean have created one specific phenomenon called gigantism. So, sea spiders, squids, worms, and many other animals, mostly invertebrates, or creatures without backbones, they're all way bigger and scarier than the versions we see in the more shallow areas. In the Pacific depths, you can see a sea sponge as large as a minivan. Or what about the colossal squid that lives in subantarctic waters and is nearly 14 times longer than the arrow squid, a type that mostly lives in New Zealand? Researchers found many of these underwater monsters in the abyssal zone of the ocean. Back in 2021, the researchers showed images of the giant phantom jelly. It was at a depth of 3,200 feet. Its tentacles were 33 feet long. Wow, I wouldn't like to face that one on the beach. It probably eats only small fish and plankton, but it can swim to depths of more than 21,900 feet. And down there, this giant jelly doesn't have enough food. How does it survive then? Scientists haven't figured it out yet. And there are even more questions related to the giant squid, the biggest one ever found. This monster is 43 feet long, with a weight of nearly a ton. Imagine if those tentacles would grab your car, or something like that. They would smash it like it was a toy. There's no light in the abyssal zone. Sun rays just can't penetrate that deep. So there's no algae or underwater plants there. Local animals mostly eat snow. Marine snow is not like the regular one you build a snowman with. It consists of any small flakes or remains that fall from the surface of the ocean. Maybe even some leftovers that animals up there couldn't eat. So it's not much, but apparently it's enough for very large creatures that hide deep down there, like giant squids. Squids that generally live at such depths don't bother going after their prey. They just wait until the poor animal swims right up to their long tentacles and falls into a trap. It may not be the best method ever, because not many animals will even swim into these dark, cold parts. But it's the method that saves energy. A giant squid eats only 1 ounce of fish daily, which is approximately 45 calories. That's nearly 50 times fewer calories than an average person should eat per day. So when a squid gets one fish, It saves it for a couple of days. I hope giant squids won't get the idea to go to the surface and look for food when there's not enough of it in the abyssal zone. And I hope even more that giant Greenland sharks won't get that same idea. You can find them at depths of up to 7,200 feet. They're twice as slow as we usually walk. They swim at a speed of 1.12 feet per second. Their slowness is part of the energy-saving mechanism that creatures down there need to survive. But they can speed up in the form of short bursts when they need to catch prey. But they kinda change their diet from predator to scavenger, considering their environment. There will be more leftovers falling from the surface than animals to go after. Greenland sharks grow just 0.4 inches per year, and they're mostly 20 feet long, which means they live for a very long time, sometimes up to 400 years. They also have a slow metabolism, and that's one of the main factors for their long life, too. Greenland sharks like to spend their time in cold waters. They're adapted to that, since their tissues have specific chemical compounds that prevent the forming of ice crystals all over their body. That means they have some sort of natural antifreeze. So what makes them so big? Scientists are still not sure, but some theories try to explain it. There's this thing called Kleiber's rule that says bigger animals tend to be more efficient. Just take a small fish and compare it to a whale with a mass hundreds of times bigger. The whale has a greater metabolism. It conserves energy more efficiently and loses less of it to the surroundings through heat. Moving on, bigger animals can ingest bigger prey. They're more likely to go through tough issues in their environment or defend themselves from predators going after them. Also, the body gets bigger when temperatures are lower. The Greenland shark is a perfect example. So are giant sea spiders. Sea spiders are generally common, and you find some very small ones at 0.04 inches. But in deeper parts of the Antarctic, they become 3-foot-long giants. They grow so big because the cold water has more oxygen. That way, more of it diffuses into the animal's body, and that allows it to grow bigger. Yeah, both as a creature and a nightmare. And how about this giant tube worm? Researchers found it accidentally while they were exploring the mysteries of the Pacific Ocean floor. They stumbled upon unusual hydrothermal vents. Volcanic heat is a thing that gets them going. As water seeps down through faults or cracks in the rock, these vents change their direction. When the water gets out of the vent, it's rich in different minerals and chemicals. Most animals wouldn't survive being around this toxic soup of chemicals, but not these tube worms. They came as a true surprise, because not only are they not bothered by these toxic vents and the almost boiling temperature of the water, but they developed entire ecosystems there. They're unique because they don't need sunlight to survive. Instead, small bacteria are their main source of energy. That bacteria gets their energy directly from these toxic chemicals. So it's not photosynthesis, but a process called chemosynthesis. And these tube worms don't have mouths. These bacteria live inside them. Strange story, huh? Plus, these scary worms reach up to 8 feet. Giant isopods are no better either. They lurk at the depths of the ocean of 1,640 feet or more below, far away from the sunlight, looking like some monstrous wood lice. They spend most of their time on the seabed, hoping to find some food falling from higher levels of the ocean. Check out their small hooked claws at the ends of their legs. Isopods use them to remain more stable while moving around the ocean floor. Since there's no light, they have long antennae that help them feel their way around. These sensory antennas are about half the length of their body. Giant isopods have pretty big eyes compared to their body size, too. They can grow over 12 inches from head to tail. And these fellas are really patient. Remember how we said animals down there rarely get food? Sometimes they need to wait for years to get a proper meal. That's why their metabolism is amazingly slow.
5 years later.
They can go for 5 years without eating anything. Imagine that. I get hungry just talking about this. In 2006, a biologist did research to compare the differences between the shallows and the deep sea regions. He realized the deep sea mirrors the island rule. First, isolated parts of land develop biodiversity you won't find anywhere else. Second, small-bodied life there grows much bigger when it's isolated, compared to life on large land masses. Resources are limited, but also competition and predators. And we don't know much about these deep-sea creatures. It's too expensive and too complicated to carry out such research, so we'll just wait for more raging storms to show us at least part of the monstrous world cold ocean depths hide.
If you've ever driven over the Rocky Mountains, you've probably seen road signs for the Continental Divide, the backbone of North America. All watersheds to the west of it run into the Pacific Ocean, and everything on its eastern slope goes straight into the Atlantic. There's just one creek in Wyoming that couldn't choose one side and drains into both oceans at the same time. Two Ocean Creek begins its journey high up in the Teton Range. The snow-capped peaks provide the perfect backdrop as the creek starts its descent, winding its way through alpine meadows and dense forests. As the creek continues its course, it gets to the Two Ocean Pass. This is the geographical crossroads where the creek splits into two branches, the Atlantic Creek and Pacific Creek. The Pacific Creek goes westward and becomes part of the larger Snake River watershed, bringing its waters to the Snake River, which eventually merges with the Columbia River and, finally, reaches the Pacific Ocean. The Atlantic Creek heads eastward and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers struggling to find the Northwest Passage between the two oceans never knew they could have used the creek. They would just have to use really tiny boats. Some scientists believe that cutthroat trout had better luck in that way. They managed to migrate from the Snake River to Yellowstone River, most likely using the Two Ocean Creek. Technically, fish can travel over 6,000 miles to cover the whole distance from sea to shining sea in fresh water. The creek could be just perfect for that journey. There are hiking trails in Grand Teton National Park that lead to Two Ocean Pass. If you feel adventurous enough, you can stand at the literal crossroads of the continent and see the beginning of two aquatic journeys. Lonar Lake in India popped up literally out of nowhere around 52,000 years ago. Newer data says it could be much older, probably over 500,000 years. At first, scientists were sure that the lake was in an ancient crater of a long-extinct volcano. But then, geologists made a detailed analysis of the soil and water and found out that Lonar Lake has a space origin. The minerals found in its soil are similar to those found in moon rocks brought to Earth during the Apollo program. The lake is an impact crater left by a huge meteorite, which was almost 6 times heavier than the Empire State Building. The impact was so strong that the volcanic rock melted and turned into glass. In 2020, the lake, which was already unusual enough, suddenly turned pink. It wasn't a part of an early Barbie movie marketing campaign. The detailed analysis showed that the water contained an increased level of unique microbes. They accumulate on the surface and emit some pink pigment. After a while, the microbes settled to the bottom and the lake became transparent again. Flamingos that got their food from the lake also got to taste some of the microbes and became an even brighter shade of pink than usual. One of the most famous sights of Yellowstone National Park is the Grand Prismatic Spring. It's one of the largest springs in the world, and it's inspired people who have seen it since at least the 19th century. Back then, a group of trappers mentioned an indigo blue lake boiling like a huge cauldron. Decades later, expeditions came to the spring to study it better and explain its unusual appearance. But because the spring at its widest point is longer than an American football field, they had to build a special vessel and travel far from the shore. The scientists traveling in the boat never wore life vests. They knew those would be useless if the boat tipped over. The water in the middle of the spring is of near boiling temperature. and those vibrant colors are the result of extreme organisms living in the hot water. The temperature changes as you travel away from the center. Different species that don't mind the heat have settled in different parts of the pool, giving it its famous diverse pigments. Back in the early 20th century, someone got the interesting idea to try to irrigate a part of Nevada's Black Rock Desert. They drilled a well and found lots of water, but it was near boiling temperature. The water was clearly not good for agriculture, so the human-made geyser was left abandoned. Over the decades, it slowly turned into an impressive cone of calcium carbonate deposits. Then, in 1964, a geothermal energy company drilled another well close to the first one. The water they had found was of the same temperature. This time, it wasn't hot enough for their needs to produce energy, so they decided to cap the well and leave. But water managed to get up and out, and it completely dried up the first geyser. The second one, which got the name Fly Geyser, is still flowing burning hot water rich in minerals. The cone is multicolored and looks like it's not from this planet, thanks to the algae living in it, which love the heat. Every summer, Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just right for the riverbed to turn bright red, yellow, green, blue, and black. We owe this beauty to certain aquatic plants growing in the river, a special type of riverweed. During the wet season, the river moves fast and the sun cannot get to these plants. During the dry season, there isn't enough water to feed them, so the time in between the seasons has the perfect conditions for this colorful show. It doesn't happen anywhere else in the world. At some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours. In August 2014, a man in Tunisia was going back home from the north after doing his business. It was a hot summer evening and he was dreaming about water when suddenly it popped up right in front of him. There was a whole lake in the middle of the desert, and the man was pretty sure it hadn't been there several days before. The new body of water got the nickname Mysterious Lake and actually became a great mystery. Hundreds of people came here to swim in the clear, cool water. The lake became a popular place, but a few days later, the water turned dark green. The locals didn't care about this and continued to bathe in the lake. But when scientists and geologists arrived at the place, they announced that the water was dangerous to swim in. The lake was stagnating. It didn't refresh itself from underground streams, and the rains didn't feed it either. That's why the water became moldy and dirty. The lake contained algae and a lot of harmful bacteria dangerous to the human body. Scientists also found out that the land in this region had phosphate deposits. This substance can decay. But even that didn't stop people from bathing in the lake in the middle of the desert. How it got there remains a mystery. Some experts think that heavy rains have filled a hole in the ground with water. Another, more popular theory says that an earthquake had formed the lake. The seismic activity must have torn the Earth's crust above the water table, and then underground springs had filled the crevice. So, in theory, the lake could drain back out one day, just as suddenly as it had appeared.
Imagine a world where instead of water, the oceans are made of methane. Yeah, that's right. Instead of swimming in H2O, you'd be paddling around in CH4. It's like Mother Nature's version of a fizzy drink. Such oceans actually exist on one of Saturn's moons called Titan. In fact, the methane and ethane on Titan play a similar role to the water on Earth. They cycle through the atmosphere and form clouds that eventually rain down onto the surface. They were discovered by the Cassini-Huygens space probe, and apparently, our entire planet's oil reserves could fit in one of Titan's puddles. Even the desert sand dunes on Titan have more organics than all of Earth's coal reserves. Who knew that Titan was the place to go if you're ever in need of fuel for your car? Now, obviously, there are some things that distinguish methane lakes from our water ones. First, the temperature on Titan is around negative 290 degrees Fahrenheit. It's like taking a dip in a giant glass of liquid nitrogen. Not exactly ideal for a beach day, is it? Methane is also less dense than water, so if you were to go swimming in such an ocean, you'd float like a balloon. On the bright side, it would make doing the backstroke a lot easier. Next, while water waves can be pretty majestic, unfortunately, we can't ride any on Titan. Cassini didn't detect any big waves there. Maybe it's due to low seasonal winds, or the fact that some of the lakes are much smaller than Earth's lakes, but we don't know for sure. Also, I know what you're thinking. If the oceans are made of methane, could you set them on fire? Technically, yes. Methane is a highly flammable gas, so if you were to light a match in a methane ocean, you'd get a pretty impressive but dangerous blaze. So, given all these differences, the question arises, what would a planet with such oceans look like? Well, we can make some guesses by looking at Titan. First of all, its atmosphere, composed primarily of methane, would be incredibly thick. Titan's atmosphere reaches nearly 370 miles into space, and the atmospheric pressure there is 60% greater than Earth's. So, if you ever wanted to experience the feeling of swimming super deep in the ocean, now's your chance. Also, methane is a powerful greenhouse gas that traps the sun's heat really well. That's why our planet would warm up faster than a sauna. You may ask, why is it so cold on Titan then? This is because this moon is very far from the sun, and light doesn't reach it well. But if we place our planet somewhere in the middle, then the temperature may even be quite comfortable. Actually, methane oceans on a planet could really spice up the climate. The planet would be a breeding ground for methane clouds. Just like on Titan, it could form an orange-colored haze, or smog, that would make our planet look like a real mystery. It would be difficult to see us from space without some special telescopes. And let's not forget about methane storms. They would also occasionally drench the surface, so remember to bring your umbrella. But hey, at least the heavy carbon-rich compounds would make for some pretty sweet dune fields. And finally, the most important difference. While water oceans on Earth are teeming with all sorts of creatures, we're not sure if there's any life in methane oceans on Titan. If there is, they'd have to be pretty tough to survive in such extreme conditions. So, if life on such a planet exists, it would be very different from what we're used to seeing on Earth. For example, microbes might be able to handle it. These tiny resilient creatures can survive in a wide range of environments, including extreme ones. So it's possible that microbial life could exist in methane oceans. And what about us and animals? Well, scientist Robert Zubrin thinks that Titan might be the perfect place for humans to colonize in our solar system. According to him, this little moon has everything we need to survive and thrive. And if it's possible on that moon, then it could work with a planet too. For starters, we'd need some oxygen to breathe. We could use nitrogen and methane in the atmosphere to create breathable air and rocket fuel. We could also use these elements to make some fertilizers and grow plants. Next up, we'd need water. Since the oceans are made of methane, we can't exactly drink them. We'd need to find or create sources of water. Scientists believe that it actually may be hidden below the surface on Titan, together with some ammonia. We could use it to drink, or create even more oxygen. So, with all of these resources, we could create a self-sustaining colony even in a place with methane oceans. Piece of cake! Although, there are always alternatives. Maybe we could become methane breathers, evolve into organisms that use methane instead of oxygen. For example, we could get some large lungs because we'd have to inhale a much larger volume of air, since methane is less dense than oxygen. But this is pure sci-fi. Methane oceans are not the only unusual oceans in space. It turns out that seas on diamond planets may be even weirder. Take WASP 12b, for example. This exoplanet, located about 1,200 light-years away, might have oceans of tar. That's right, tar. The planet has more carbon than oxygen, which means its crust is probably made of things like diamond and graphite, instead of your average silica-based minerals like granite. Imagine stepping on this planet, and the first thing you notice is that the beaches are made up of black goo. It's like stepping into a nightmare, where you're trapped in quicksand made of sticky sludge. So forget about the sandy beaches and crystal clear water you're used to. Here, you'll be living the pitch life. Your swimwear will be replaced with hazmat suits, and you'll need a sturdy pair of boots to walk on the sticky surface. But in reality, WASP 12b is not the place to look for geology of any kind. It's simply too hot for anything to survive, let alone thrive. But there might be smaller, similar exoplanets where we could potentially live. Now, you might be thinking, tar oceans? That's crazy talk. But did you know that there's a 246-foot deep lake of natural asphalt here on Earth? It's called Pitch Lake, and it's located in Trinidad. It's formed when oil is forced to the surface, and the lighter components evaporate, leaving the thicker, heavier pitch behind. And guess what? This lake is home to a thriving ecosystem of microbes. So if you want to live on such a planet, at least you won't be alone. You'll have plenty of company in bacteria, fungi that love to feast on carbon found in asphalt, and archaea that live on methane. And finally, there are oceans of molten rock. That's right. Imagine a world where the floor is lava isn't just a game, but a reality. Welcome to 55 Cancri E, a planet so hot that the entire hemisphere facing its star is covered in magma. It's like a scene out of a heavy metal album cover. But don't worry, the other side of the planet is slightly cooler, so you can at least step off the lava and catch your breath. If you're feeling adventurous, you could always hop over to Koro T7b, another super Earth where the lava ocean is just as scorching. But this time, the night side doesn't offer much respite either. It's still seeing constant volcanic eruptions, like some sort of fireworks show. Scientists are scratching their heads trying to explain why these planets are so hot, and why they haven't cooled down yet. Maybe they're just really good at retaining heat, or maybe they just have a bad temperament. Either way, it's probably best to stick to playing the floor is lava on solid ground, and leave the real lava planets to someone else. All this diversity of oceans shows us that the universe is always full of surprises. It never ceases to amaze us with its creativity. Although these oceans are not suitable for human exploration yet, they challenge our understanding of what could exist beyond our world. So, let's continue to explore.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech, too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much. just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material, which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found. For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn. For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon. the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that ice quakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started. But not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes, and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with irregular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship, the big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next to water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under half an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses. Many terrifying animals live deep beyond the waves, like this vampire squid living 3,000 feet below the surface in almost complete darkness. This animal has a cloak, like a vampire's. That's why it's called the vampire squid. Deep down at the bottom, it can't use ink to defend itself. So this animal has developed an unusual tactic. It glows slightly to scare away predators. If this tactic fails, the vampire squid can turn its body inside out, revealing tiny spikes. When you translate its scientific name, Vampiroteuthis infernalis, it literally means vampire squid from the nether. Despite its terrifying looks, it's a harmless ocean animal. This previous creature was not from space, but this object definitely is. Before Elon Musk found a way to reuse rockets, NASA would simply drop old ones after launching astronauts into space, most of the time in the ocean or deserts. In 2012, Jeff Bezos launched a mission to find the Apollo 11 rocket. They found it by using sonar, but it was in terrible condition. It was sitting on the bottom of the ocean, not far from the predicted site. They were able to rescue the engine and reconstruct 2 of them. The most famous lost city is Atlantis, but sadly, we still haven't discovered it. However, Heraklion was also just a myth until one British pilot saw something that looked like a city while flying over the Mediterranean Sea. He reported it, and 60 years later, a group of divers went there. They were shocked when they found an entire city underwater. It was loaded with artifacts that could tell us a lot about the history of the place. Now it's one of the best underwater archaeological sites in the world. It's believed that the rising sea caused the whole city to go underwater. The Titanic sank in 1912. The wreck was claimed to be officially discovered 74 years later. In reality, though, a fisherman found the Titanic 8 years earlier while fishing in the Atlantic Ocean. He was pulling out his net when he spotted a head stuck in it. Luckily, it was just a doll's head. Years later, after the fisher had passed away, his son sold the doll to a doll collector. She did a lot of digging and research on every person who had a porcelain toy on the Titanic. She found the owner of the doll. Ava Hart was on the Titanic and had a doll with her. Ava survived the catastrophe by a miracle, but her toy didn't. Hart even wrote about the doll in her journal, and every detail matched the toy found by the fisherman. The tripod fish lives deep in the abyssal zone, around 20,000 feet below the surface. It's adapted to such immense depths and uses its tripod fins to stay still on the bottom. This creature doesn't have big eyes, but even if it did, these eyes would be useless in the darkness. Instead, the tripod fish uses its fins like antennas to detect any movement in the water. This creature doesn't have much luck when it comes to its love life, so it had to develop unique tactics to reproduce. One fish can be both male and female. The next bizarre creature is the lizardfish. It has tons of razor-sharp teeth, a huge mouth, and really big eyes, which it uses for hunting. All this makes the animal look freaky. The lizardfish lives at depths of around 11,000 feet in the midnight zone, where there is zero light. This freak of nature basically eats everything it can fit inside its mouth, from small fish to other lizardfish. On the other hand, when they see other reptile fish, they probably fall in love instead, because finding mates at those depths is not an easy task. Like the tripod fish, the lizardfish can be both male and female at the same time. When you think of a river, you usually picture it on land. Still, nature is quite unpredictable, and it created a river flowing under the ocean in California. It's running at a depth of around 2 miles. This river has everything that an ordinary river has: sunken logs, trees, and rocks. And despite its uniqueness, it's not the only one in the world. There are also others in the Amazon and Greenland. A terrifying creature was discovered near Angola's coast by a remote operating vehicle. It looks like it doesn't have a head or a body. It was sitting at a depth of around 4,350 feet below the surface. After doing research, scientists concluded it wasn't anything from a sci-fi movie, it was just a cluster of siphonophores stuck together. In 2015, some random guy was diving in Caesarea, and something shiny caught his eye. He reached out, grabbed it, and realized it was a gold coin. After that, he examined the bottom and found out that there were many more. He reported the incident to the local authorities, and they concluded that he had found Arabic treasure. The coins were made of solid 24-karat gold and were a few thousand years old, but due to the perfect salinity and temperature, they looked brand new. The coins belonged to a ship carrying cargo. It was caught up in a storm and unfortunately sank. One of the weirdest things ever discovered was found in the Baltic Sea. It's an anomaly that looks as if it was created by a different civilization. It was discovered by Swedish researchers, and they basically had no idea what it was. They had to ask tons of other scientists for their opinions. When you look at this formation from above, it's 200 feet long and looks exactly like a fallen spaceship. It's hard to believe that it's a natural formation, but spoiler alert, it's totally made by nature because the Baltic Sea has gone through many erosions throughout history. Most likely, the bizarre formation is the result of these processes. A group of divers in Madagascar were shocked when they found this 7-foot monstrosity of a knife on the seafloor. The speculation started immediately, and many said that the knife was from some giants that had fought megalodons and lived on Earth thousands and thousands of years ago. That could make a nice story, but the knife is most likely a movie prop that was lost at sea. One of the ocean's most bizarre animals is the frilled shark. It's believed that this fish is the reason for all those sea serpent stories that sea explorers of the past wrote about. These animals live pretty deep in the ocean, but sometimes they can be seen in shallow waters. It's super rare, but possible. The frilled shark has a big mouth sporting around 300 teeth. It also has a long body that looks like a lizard's, and it is truly a unique species of shark. Its prey can be half of its size because this shark's stomach is like that of a snake, and it can swallow huge fish or crustaceans. Spotting a few worms in your garden is no big deal, but after seeing a 26-foot-long one in the ocean, you will make your wetsuit a little wetter. This worm is super rare, and it's completely harmless to humans. It's actually not a giant worm. It's a cluster of zooids that are stuck together in a worm-shaped formation. They usually only eat plankton, bacteria, and other tiny things that can be found in the ocean. Probably the scariest thing in the ocean that is 100% real is the magna pinna, which can be found at crazy depths of 20,000 feet below the surface. This monster looks like an underwater Slender Man, but it's just a squid with really long tentacles that can reach a terrifying size of 8 feet. This guy has only been seen a few times, and basically, we don't know much about this creature so far.